In this video, we're going to talk about the limit of a function and begin to understand what that term or the concept of a limit means. So when we think about limits, we are thinking, well, how does the function behave as we get closer and closer and closer, as we move closer to a specific x value? So as x gets closer to some number, where does y go? So let's consider this rational function. Here we have f of x equals x squared minus 1 divided by x minus 1. And we know that rational functions have undefined values. And in this case, we can see that I cannot let x is not allowed to equal positive 1. Okay, so x isn't allowed to equal positive 1. So my question would be, how does this function behave near x equals positive 1? Now, if we consider trying to graph this function, we would factor the numerator and denominator first, and we would see that we could cancel common factors. So this function is really equal to x plus 1, but we know, again, that x can't equal positive 1. So what would the graph of this function look like? This is the graph of a rational function, ends up looking like a line with a slope of positive 1 and a y-intercept of 1. So I'm drawing this line here, and what you'll see is if I were to connect this line, we'd get something that looks roughly like this, and at x equals 1, we would have a hole, right? That hole exists at 1, 2. So this is the graph of a line. This rational function is linear, and there is a hole at the ordered pair, positive 1, 2. So, thinking about this brings us to our concept of what a limit is. The limit as x approaches positive 1, which is an undefined value for this function, that would be the same as writing the limit as x approaches 1 of x squared minus 1 over x minus 1. And what we see is, where does the y value go? The y value goes to 2. So the limit of the function equals 2. So that's the idea of a limit. And moving forward, we're going to learn lots of rules and properties that help us find limits without having to graph them. And not all functions have limits that exist. They don't always tend toward a specific point. And here we see 3 graphs that just explain to us not every function has a limit that exists. So this first graph is a step function. So we have a line with an open circle and a closed circle. And if we look at approaching x equals 0, where we have this break, we'll learn that that's called a discontinuity. As we look at approaching x equals 0 from the left and also from the right, what we see is that it does not approach a specific value, right? From the left, we would be approaching y equals 0, and from the right, we are approaching y equals 1. Okay? Similarly, if we look at approaching x equals 0 on the second graph, as we go towards 0 from the left, we're going down to negative infinity, and as we approach x equals 0 from the right, we're going to positive infinity. So we're going different directions as we approach that number. The limit does not exist. And then on our third graph, this oscillating curve, what we notice is that there is no specific value that it approaches either. It's oscillating wildly as we approach x from the right. Even though as we approach x equals 0 from the left, we are approaching a specific point. From the right, we are not. Okay, so in all of these graphs, the limit as x approaches 0 of the given function, u of x or g of x or f of x, all three of these functions, what we know is the limit does not exist. So that's the general idea of what we think about with a limit. Okay, so a limit is, as x approaches a certain number, where does my y value go? And is it consistent? Do all of my y values tend toward that number? Or does the graph approach different y values from either side?